Okay, so hello everyone. My name is Belle. I'm here together with Dr. Ehrlich, who is investigating the neuromechanisms underlying cognition, for instance, decision making, integration of perceptual information, and motor planning. So, Dr. Ehrlich, can you tell us more about your research?
Yeah, so as you said, our lab is interested in the neural mechanisms of cognition broadly. We quantify normal and perturbed behavior and neural activity in mice, rats, and humans, and also synthetic agents like neural networks, artificial neural networks, and using statistical and computational models. Some of the major directions of the lab right now are movement planning beyond two alternative force choice, or decision making beyond two alternative force choice, and neuroeconomics, economic preferences. And the thing that I'll be talking about in the conference is a project that's about cognitive control. So those are kind of the major directions of the lab.
Yeah, can you? That all sounds.
So we were going to talk about how should computational neuroscientists and experimental neuroscience work together. Right.
Yeah.
During my PhD, I was in an experimental lab, and my background is in computer science and neuroscience, and so I had a lot of programming experience, and I had a lot of math, but I didn't really have a lot of experience with, let's say, like the math that's used in neuroscience, in computational neuroscience so much. For example, I didn't know a lot about dynamical systems, or that was kind of novel to me. So then for my postdoc, I decided to join Carlos Brody's lab, who is a fairly well-known computational neuroscientist. And Carlos, the main reason he wanted me to join his lab was because he wanted his lab to have both experiment and computation, because he was frustrated as a pure computational neuroscientist not being able to do the experiments that would test the models that he was developing. And I've taken that to heart. And so my lab actually does both experiments and computation. And I think that's the best, is to just have it be in the same lab. And I think the best, so if we take computational neuroscientists in the broadest sense, that is any neuroscientist that doesn't collect their own data. So some of them are like going to be pure theorists, some of them going to do more data analysis, some of them may be more like developing methods for visualization or dimensionality reduction. The best ones have to collaborate because they need to work with data. But things are changing rapidly, and this actually touches on sort of another question that was in the list, which is about the internet and big data. And so I think we're in a new world where, first of all, the data sets that people are collecting are so amazing and massive. Like, Matteo Carandini and Ken Harris's lab, they've published these neuropixel recordings from mice where they've recorded, I can't even remember, like 10,000 neurons at a time or whatever. And they put it out and they published a paper, but then they put the data out there. And you could probably analyze that data for your whole life. And so now that there's these amazing public data sets, I think there's a lot of room for both what I would call like data scientists, data science neuroscientists, and computational neuroscientists to not really directly collaborate in real time, but do sort of analysis of public data sets. And I think that's going to happen more and more because the tools like these imaging data sets and two-photon imaging data sets and NeuroPixels data sets, they're just so big and they're so rich. So there's a lot there. So I actually would like to see, in a way, fewer experimental labs and more labs that just do data analysis, methods development, and theory, because I do feel like neuroscience as a community is just sitting on a mountain of data that we don't understand. And we need more people thinking about all the data and fewer people adding to the pile. That's my humble opinion.
Well, there's this saying, right? So the last question is gonna go back to you. What motivated you to study neuroscience? What do you like about the field?
Yeah, I naively thought when I was a student, I think even going back as a high school student, I thought that the brain was really interesting. It was like the last frontier of human biology. That I naively thought we understood how the rest of the body works. Now I realize the immune system is like just as mysterious as the brain. But I thought it was this really interesting hard problem. Also, neuroscience it spans all the scales, right? You can study neuroscience at the nanosecond level, studying how like glutamate binds to a receptor, or you can study it at like the years, like studying aging or other processes, learning over a lifetime, and where the time scales like months, years, decades. And same with like spatial scales, you can study molecules or you can study social behavior. So I love the fact that it just spans all these scales. I also like that I can do some wear different hats. Like I can do some programming, I can build some models, I can also like build an electrophysiology rig or do a surgery, and basically get to like do all these different things so I don't get bored. And I also like that it, neuroscience, at least behavioral neuroscience, touches on like philosophy, questions about consciousness and free will, and touches psychology and economics and decision making. And so I get to talk to a lot of different people, and I like building stuff. So all the hardware that we use to collect data, I get to interact with engineers, and so I think that's what I like most about it, I guess. In terms of what motivated me, I think I still care about public health a lot, and I think that we all have an obligation to think about how, in the long run, our work can improve the public good. And that doesn't necessarily mean like disease, but at least improve the world in terms of the way we think about public policy. So some of our work on economic choice, like we want to understand how stress influences choice, because there's some evidence that people under chronic stress make bad economic choices, and this could contribute to the cycle of poverty. And so, we think, if we can develop an animal model that demonstrates this, one, maybe we can depoliticize the debate around poverty, and also maybe come up with new interventions which focus on like the stressful aspects or things like that. So I continue to be motivated to like, I like to have fun on a day-to-day basis, like, thinking about fun things and talking to smart people, but we do like try to keep a big picture motivation of, we're getting paid to do, research, and we should pay it back, like, do something to help everyone. That's how I try and stay motivated.
So yeah, that's all the questions I have for you. Yeah, thanks. I'm gonna stop the recording now.